Hello, my name is Uwe Ortmann. I'm the head of sales at PicoQuant Berlin, Germany. I'm standing here with Professor Carol Gryczynski from the TCU Fort Worth and the Texas North University, also in Fort Worth. Carol, we've been here at the Timeresolved Fluorescence course in Berlin. Being a CFS member, what do you see the comparison between the traditional course you held in Baltimore and now the Berlin course?
Essentially, we started the course, I believe it was 1992. I was not an official member yet of CFS, but originally it was an idea of my brother Ignacio, a little crazy. Kind of funny because the first course when we were working on, nobody believed anybody will come. It was a belief in the field that we will have some participants because it was essentially an awakening of biotech. That was essentially the assumption. And the first course, we got quite a few participants for that time. It was, I think, around 30 or a little more. Quite prominent guys. And with time, it was developing to more and more. And then somewhere at the beginning of, or end of 90s and beginning of 2000, it was easy to get over 100 participants. Let's say, the important thing for us when the course was starting, and it was essentially principle for Joe, it was to have essentially all company involved. And the idea was to propagate the knowledge of fluorescence and practical knowledge especially. So we had essentially all companies involved, and that's how PicoQuant joined us. I believe it was 95 or something like this. And from the beginning, we had essentially all main companies participating. So our goal was essentially to put the theoretical knowledge and eventually practical applications. And somewhere at the, let's say it was 2003 when we started in Europe, because we've seen a high participation from Europe, and it was a good time to extend to Europe, I believe. And that's where eventually in 2004 we finished in Baltimore, and eventually later on in States we did two courses where you were also present in 2007 and 2009 in Fort Worth. But let's say from 2003 everything is here. Originally it was exactly like we had in Baltimore, and at this point now it's a little shifting. We're still kind of having quite few participants here in Europe, so the courses are essentially very similar in the same line. The original course in '92, it was something very new in the field. We were probably the first at this time doing this, and that was quite important. Later on, number of courses came up. And you know, ISS organized very similar course, which I participated in also in Chicago. And one kind of interesting thing, in the first course participant was Amasi Paryazami, and now one of the best course in microscopy, which is organized in States, is organized in Virginia, and he does it in very similar way, like we were doing. So it's kind of sprouting up now quite well.
So what's the advantage of the course participants to take this course and really take that home to their own research lab?
It's probably thought mostly for the new researchers in the field. It doesn't mean young researchers only, because we had many times, and still we have quite a few professors coming. Anybody who wants to move to the field of fluorescence is kind of speedy way of getting the information about fluorescence, what fluorescence can do. And I think it's quite efficient. We always had a very good feedback out of this participants. And typically, at the first time, was very difficult to get participants. We had like 30s, and later on, it was growing really quickly. The message was essentially spreading out. The one difference you were asking what was, typically in our course in Maryland, it was longer course. The same in Fort Worth, it was full week. We had many more invited speakers to kind of spread the knowledge. But I think fluorescence grown now. So it's important to have everything, but we cannot have basic fluorescence and, for example, microscopy, which becomes a huge field right now. Yes.
I mean, this course is dedicated about time-resolved fluorescence spectroscopy.
Yes.
What do you see the advantage of time-resolved fluorescence versus?
You know, time-resolved fluorescence is extremely important if we're looking for the dynamic processes, anything which change in the time. Steady-state information is essentially an average through time, and time-resolved gives us the possibility to see the events in time. So any kind of binding, conformational change, any kind of rotational motion, everything we can see by time-resolved fluorescence spectroscopy. And this becomes really powerful right now. If we look for any kind of biomedical diagnostics, anything, and of course, fluorescence microscopy is the best example, and this year Nobel Prize was exactly kind of glorifying the achievements of fluorescence and microscopy.
How would you say, let's say in 5 to 10 years, how How would time-resolved fluorescence be part of the research? What would you
I think
picture?
most of the fluorescence will move to time resolve. This would be a must. We are looking for more and more precise information about the molecular system. So I think the time resolve will be key now, and eventually two things which becomes really important. Microscopy will stay essentially a focus for many, many years, probably forever. What we are gaining out of the time resolve, we are gaining the molecular information. We can get the interaction. And with the development of new probes, especially long-lived probes, we have essentially a huge impact of this kind of technologies for any kind of discovery in biology and the biomedical field. So in the future, if we want to see the fluorescence, it will be always time resolved, will be always in biomedical field as a biomedical diagnostics. Obviously, microscopy would be a key component right now, but I think in the future, what I really think, if fluorescence is to proceed further, we have to include optical imaging for small animal and tissue imaging in sense of even human body imaging. So red probes, red long-lived probes will be crucial, and technologies which we are introducing right now, if we can apply this to human and compete with technologies like PET and MRI, that would be probably the future for next 10 years for fluorescence.
Well, thank you very much, Carol, for your
Thank you.
for these nice words for the course.
Thank you.